deal. Hello. So, I'm Matt Kelly. This is Ryan Reynolds. We're going to go over advanced network traffic manipulation. So, just Alice and Bob with Bruce Schneider in the middle. So I'm Matt Kelly. I'm a senior consultant at EY, Ernst & Young. I'm on Twitter and GitHub. Everything I retweet is an endorsement. From Chicago. I live in Houston now. I do pen testing, red teaming, that type of stuff. I work in the attack and pen division.
Yeah, I'm Ryan. I work at a professional services firm called Crow, and I'm a manager focused in pen testing. Matt forced me to put in that I cheat at fantasy football, so a little background there. I don't know anything about football, so I outsourced my team draft to someone else. I don't know, some call that cheating, tomato, I don't know, whatever. But I won. Ravensec blog there, just a little blog that'll have this slide or these slides and some notes around this presentation that you can check out.
So this is kind of the why of the talk. There's two main points. The first one is the attacks we're about to cover are practical, and they do have a huge impact on your network. And the reason we're emphasizing this point is I see a lot of great presentations on attacking protocols like ARP, LMNR, NetBIOS, or attacking EIGRP or HSRP, but they don't have a lot of impact. They don't have something that I can translate when I'm attacking a network and feel comfortable doing or feel comfortable exploiting and getting results from it. So that was a big thing of us changing our mindset and saying, how can we use this on an internal network? How can we use this in a post-exploitation attack to move around laterally or perform privilege escalation? And we've also seen a large focus on network security historically, and we're, as an industry, often shifting towards AppSec. But these issues never went away, despite our focus on application security. And I guarantee you, I don't know the makeup of defenders versus offense in this room, but I guarantee you you're going to see this in every network you encounter or your network here. One of these things we're going to cover. The other thing is these vulnerabilities can be fixed that we're going to talk about. Our talk is broken up into how protocol works briefly, the vulnerability, attack, and countermeasures. Oftentimes the attacks we go over are dismissed because they can't be fixed, and we're going to challenge you to say they can. And everything we've covered here, we've helped organizations fix. And between Ryan and I, we've been at a lot of organizations, and these things can be fixed. So again, on the practicality, real attackers, we see these post-exploitation techniques used. For instance, man-in-the-middle ARP spoofing that I'm about to cover. A lot of people say that's cheating, or it's not a valid attack vector because you can't fix it, and that's not true, and we're going to tell you how. And we'd argue that TJX would probably argue that this is a valid attack vector. And that was 2007, and we still see ARP spoofing everywhere we go, ARP poisoning. So the topics we're going to cover, we tried to avoid some of the more esoteric attacks, or the ones that we don't see realistic attack vectors coming from. Maybe in the future that'll change, but at this point in time, we're not going to be focusing on STP root bridge attacks, because that's not a realistic internal attack vector to us. What we will cover is layer 2 manipulation attacks, such as DTP, VTP attacks, ARP spoofing, gateway redundancy attacks, so VRRP, HSRP, some name spoofing attacks, and then route update attacks, along with a few other tips and tricks on taking a vulnerability, attacking it, and defending it. So with that, we'll move into ARP poisoning. Who all here has heard of ARP poisoning? So the majority of the room. So I'm not going to spend too much time on how this protocol works and how to attack it, because there's a Yeah, so thanks to Iron Greek for this quote shitty looking graphic. So briefly, ARP is not authenticated. That means that I, as a bad guy, can send out an ARP packet and tell you that I'm now the gateway, and the gateway, I'm now you. That's all we're going to cover. Look it up otherwise. There's some great tools called Kane and Ettercap that I'm sure you've all heard of that attack these very well. Ettercap works great for post-exploitation too, because it's standalone EXE. And then there's a million other tools. If you want to see how to do it, there's a lot of great videos with death metal in the background on YouTube. So with that, we're going to move into countermeasures. So the things we're going to cover is DHCP snooping and dynamic ARP inspection, which I would argue is one of the most widely misunderstood networking concepts. Then we're going to cover some detective controls, because I know I got a lot of SOC people in the room, or more blue team focused. So DHCP snooping and dynamic ARP inspection, what's that? Well, this is how you fix ARP poisoning. It's also what we're going to cover today is probably being the most intense fix. However, it is extremely effective if done well, and it is very doable. We have had many organizations do this over the years. So DHCP snooping basically tells the switch to look at DHCP packets and build up a trusted table tying the IP and the MAC to a port. It also looks at every DHCP packet coming in, and if it's not on a trusted port, drops it. So this is the misunderstood part. A lot of organizations think, I enabled DHCP snooping, how did you still ARP poison? Well, that's only half of the picture. So the other half is dynamic ARP inspection. That's where we're actively blocking. So it takes that table that we just built from DHCP snooping, and it actually acts on that. So I get an ARP packet coming from this port that is not the same IP and MAC tied to that port. So I'm going to drop it right away. There's two different types of ports. There's trusted ports and untrusted ports. They're pretty basic concept. Trusted ports can have multiple MAC addresses tied to it. These ports you want to use pretty sparingly. You're going to use it on your trunks, your ports where a lot of movement is going on. The untrusted ports are going to have that action applied where it's blocking unwanted MAC address entries. So the important things to note here is the rate limit by default in a Cisco environment is 15 frames per second. So that means 15 ARP frames, and it'll actually trigger that port to be blocked. This is probably a bad default setup, so if you guys do this, you want to move that up. The reason that is there's a lot of devices that you have to support that have really bad TCP IP stacks. These are going to be your printers, your phones, that just blast out ARP traffic. If you've ever Wiresharked some printers, all it is ARP, ARP, ARP. You're going to block these ports, so you might have to make trusted ports throughout your network, but more than likely you just have to increase this rate limit. The other thing is, make sure you audit your trusted ports. You might be tempted to put these in conference rooms, but those are the ones I'm most likely to attack. So just make sure you look at these. I've had organizations I've gone to that went through the trouble of implementing this, and then they forgot to change my port to an untrusted port, so I was able to still do this attack. So the important thing is just putting both of these in place, and it is a very doable goal. A lot of places view this as an insurmountable thing to do on your network. I would challenge you to do it piecemeal, one at a time. As you touch a switch, implement this on the local VLAN. This is applied to your VLAN or your local subnet, so it is quite the fix. You have to do this on every switch, but it is very doable, and this will block ARP poisoning attacks. The next one, for more of the countermeasures on the client side, Symantec Endpoint Protection has a really great feature called anti-MAC spoofing. What this is basically it alerts on ARP poisoning attack taking place. It's pretty effective if you have your IR guys responding to these alerts. To our knowledge, this is one of the very few clients from like a endpoint protection standpoint that actually detects on this attack. ESET ENOD32 supposedly does. I haven't seen it in place, so I can only speak that it has the capability. But this is one we see regularly as actively defending this. Really cool feature. The other cool thing, it'll detect static challenge keys. So when I'm doing an ARP poisoning attack, I'm probably going to be challenging you with integrated Windows off with a static challenge of 11223344 that comes by default in every major tool. So Symantec Endpoint will actually detect on that, which is really neat. So take a look for those. Then your other options that we see every once in a while is ARP Watch, which is a open source tool to detect ARP spoofing. And then there's some commercial off-the-shelf tools, so Blinky boxes that do this as well. I would not recommend you go with the COTS approach. We see a lot of these very expensive boxes that organizations buy, and then you have to deploy these on every subnet. Same with ARP Watch, and monitor for these attacks, which is quite the intensive operation to do, and it's very expensive. But you can do it. So with that, I'll go into IPv6, man in the middle. So some good talks on it lately, but the very gist of it is you might be saying, well, you can't do network traffic manipulation because I encrypt everything with IPsec. That's a very misunderstood concept. IPsec is built into the protocol. It's not enabled by default. And it's very difficult to enable too. So with that, how IPv6 works at a very high level. So you take DHCP and IPv4, which assigns your DNS information, your IP information, all that. And then we split that into basically three major protocols. We got router advertisements, which we send out, which you can somewhat think of DHCP, tells you your default gateway. Then you got DHCP v6, which can do some of the stuff router advertisements do. Usually you use this for your DNS information. You also have SLAC, stateless address auto configuration, and this basically is where the client figures out its actual link local IP address. And the important thing to note is Windows by default ships with IPv6, same with Macs and Linux. They're enabled by default on a network, which is really useful for us since we're pen testers. And clients prefer IPv6 to IPv4. Right now, if you look in your Windows environment, I would bet if you look on your DNS server, you're going to see some IPv6 entries in there that you say, wait, I don't use IPv6. Well, that's Windows happily configuring things for you. So the vulnerabilities we're going to go over, there's Slack attack, which we'll cover next, neighbor advertisement spoofing attack, which I haven't seen a lot of great details on. Then there's fake DHCP v6. We're not going to cover that in this presentation, but it's out there. So Slack attack, how it works. So remember, IPv6 is enabled on your network, but I would bet 99% of you do not actively use IPv6 intentionally on your network, on a local network anyway. So now it's enabled, but we don't have many of these protocols that are required to make it function. So I, as a bad guy, I can't do ARP spoofing because you just fixed that. So now I still want to man in the middle of your traffic. So how do I do that? I start my Slack attack. I send out a router advertisement to my local subnet and tell the hosts, hey, initiate Slack and set me as your default gateway. Then the hosts derive their link local addresses based on that information, sets me as the default gateway. I send out DHCP v6 information for your DNS server. Hosts now automatically prefer to send traffic to me over their IPv4 equivalent, which is really awesome. This is enabled almost everywhere. And then I configure pass-through, and they don't even notice. So this is a pretty cool attack. So how do we actually do this attack? So our kind of tools, tactics, and procedures. There's a few great blog posts on this. One of them, the basic gist of it is we need to set up IPv6 on our, in this case, Linux box. We're going to set up sysctl to do basically IPv6 forwarding. Then radvd, which is a utility to send out those malicious router advertisements. In this one, we're going to have to do some configuration based on Ryan and I's lessons learned doing this attack. Most of these attacks we're going to describe, if you don't vividly understand the protocol details and how these attacks work, I would not recommend doing them on your network. Some bad things can happen. But then DHCP-v6 to set up the DNS information. Then NAT-PDD to do NAT pass-through. So the important things to do when this attack is router advertisements, their default going to be multicast. They're going to send out to everybody, and all of a sudden you're man in the middling, a whole subnet, which, depending on the configuration, that's a ton of traffic going to you. Really bad idea. Whoever's done ARP poisoning in a real-world environment, you generally only target a couple hosts because otherwise everything starts breaking, and you don't want to do that as an attacker. That's how you get caught. So you set that to unicast only, and you target only specific hosts. So you pick out a few hosts, you unicast them to them, and do this attack. And now they start routing their traffic. Despite all that effort you just put into ARP poisoning protection, now they're using IPv6, which you're probably not even actively monitoring, so it's kind of a covert channel too. The other big takeaway is the default lease time is going to be about 10 hours. So when Ryan and I have done this attack, all of a sudden we unplug and sometimes bad things happen. So you want to set that pretty low so that when you stop this attack, things don't break. And then there's some other great tools to do this. So THC 7.6, I believe both Ryan and I have used that one. That's pretty good, but just make sure you change the defaults again. The next one we're going to go over, so ARP neighbor spoofing. So ARP neighbor spoofing, think of this as literally the ARP poisoning attack for IPv6. Not a lot of great slides or blog posts on this one. This is one of those attacks that would be more effective if you are actively using IPv6. So where the Slack attack might not work well, or it's a race condition, now you're going to use this attack to basically do the same thing as ARP poisoning, except in this case it's not ARP, it's ICMP-v6 neighbor solicitation addresses. You can do this with Scapy, and it's not even difficult. Most of the time people say Scapy, when I think of Scapy, I don't want to use it. Scapy is pretty easy for this attack. Then the next one, so for countermeasures, how do we stop this? I'm going to go over a few. The main one is disable it on your internal network. Now, this might hinder adoption, but I would say most of you are not intentionally actively using IPv6 on your network. So we need to change the default configurations on network devices and clients to disable this. The next one is RAGuard. So that's a Cisco feature to prevent router advertisement spoofing, basically. So I think DHCP snooping, kind of. And this will basically stop that Slack attack. Then there's these really cool things called Send and GCA. We'll cover briefly. Not going to be probably what you're doing on a realistic enterprise network, which is what we care about. Then there's some client controls to think about as well. So RAGuard, you configure it on your VLANs. Basically, you say, I don't want unwanted router advertisements. This is probably pretty easy for you guys to do because most of the time you're not going to have legitimate router advertisements on an enterprise network. The next one, so send GCA. This is basically a PKI way to cryptographically generate addresses. Really cool concepts, not great support at this time. This is kind of future vision. This will actually stop that neighbor advertisement spoofing attack. This probably one of the only good ways to stop it at this point, unfortunately, but you're not going to realistically implement that on your enterprise at this point in time. Next one is disabling. So disable it on your network device and put firewall rules to prevent encapsulation. So one of the big things we do is we do encapsulation. So we encapsulate that IPv6 traffic to IPv4 traffic so that we can traverse it throughout your network. If you block that IP protocol 41, that makes that activity not possible. It's a really great way to prevent covert channels and prevent some of these attacks. And then also block common encapsulation sites too on your proxy, like Hurricane Electric. But client controls, disabling IPv6 on your Windows devices is a very smart thing to do at this point in time. I'd highly recommend it. You can do it via group policy. Also change it in your default builds. Next one, set the preference to IPv4 over IPv6. This will let you keep IPv6 to a degree in your network and prevent me from using that default setting in Windows to kind of route traffic through me. You can also disable Slack on the clients. This one, it's a great mitigating control. I would opt for one of the former options we discussed, though. With that, I'll hand it off to Ryan.
So name spoofing here. Who's heard of NetBIOS spoofing, LMNR? I think a lot of people in this room probably. So I'll go through this pretty quickly, but we'll just baseline this real quick. So when you're accessing, let's say, a share, right? You type in the host name /$C or whatever, and your host needs to translate that to an IP address. So it's going to first look in its local host file and say, hey, do I have any static entries for this? Okay, if I don't, I'm going to check my DNS cache because, hey, did I look this up already? Okay, no IP address there. Then I'm going to send out a DNS request. DNS doesn't answer me. Now, the next thing I'll go to is WINS. I'll ask WINS. That's only if you actually have WINS configured in your network, though. The Hail Mary is a NetBIOS broadcast, which essentially sends it to the local subnet and says, hey, does anyone have this host? Who are you? And so this is where we respond and say, hey, you're looking for that resource? That's us. We're right here. There are lots of tools that can be used to launch this attack. My favorite is Responder, made by Gaffey at TrustWave. It's awesome. Metasploit has NBNS spoofer, which you can use in conjunction with SMB capture. Interceptor NG is a Windows-based GUI man-the-middle attack framework. It can do a bunch of protocols, including NBNS. And then for a pivoting perspective, a great standalone tool is McGrew's NBNS spoof. And Movix did also kind of a modification of that, so it's pretty cool. But there's a lot of tools out there to launch this attack. So basically, we're just answering that query to say, hey, you can't find out where this host is. It's us. Connect to us. And now typically when NetBIOS is being used, the user has invoked something like computer browser or loaded my computer and it's trying to map all their home drives and things of that nature. So the Windows integrated auth, or the single sign-on mechanism, is trying to make that seamless for the user. So therefore, instead of them having to type in their username and password for every share that they're mapping, it just does it automatically. And so that process is going to most likely send us their credentials. So when we're doing this attack, 9 times out of 10, we're going to get their SMB or their NTLM v2 or v1 credentials. And so it's really good for us as being attackers. When we plug into the network, it's one of the first things we do to get off. So once you get that challenge response, essentially, you can attempt to crack the credentials, or you can relay it using something like SMBX. And in order to actually relay it, though, you do need to be local auth, so you have to know if that user has local administrative access anywhere. LLM&R is pretty much the new version of NetBIOS. Comes with Vista and up. Microsoft made it a little more efficient by saying let's use multicast instead of broadcast. Basically, it works like MDNS. There's a lot of blogs out there that pretty much say, why did Microsoft make this when MDNS is essentially the exact same thing? But hey, why not? So we can do the same type of attack here. I think one of the things that we run into when doing our pen tests and saying, hey, we were able to do NetBIOS spoofing and LMNR and get credentials, and that got us into the network, and then we just ran from there, privilege escalating. Clients say, well, what's the fix? All right, well, the fix is to disable it. But the next follow-up question is, well, what do you mean? You want me to just flip a switch in my entire network and turn this off? What's going to break? And so I try to help them walk through learning their network. So WINS and NetBIOS are tied in pretty heavily. Basically, DNS tries to replace WINS. So ask yourself, if you're a netadmin and a sysadmin, do you have WINS out there? Now, by default, all domain controllers have WINS, but that doesn't necessarily mean it's being used. So the other thing is, so basically, did you set up any WINS servers manually? Did you set up any WINS proxies, which all this does is forward WINS requests outside of a local subnet to a main WINS server? Do you have any servers that are on the same subnet as your workstations? Because if your workstation is doing a NetBIOS query, it can only go within the local broadcast domain. And so if it doesn't get an answer, that's fine. But if it does have a server on that same subnet as the workstation, maybe that server is actually responding via NetBIOS. You might not know unless you're actually looking how your network is set up in terms of our servers on the same subnet as workstations. Do you have any legacy systems out there? Basically, if you're XP and above, Microsoft made a strong push to roll out and fade away from WINS and NetBIOS. They basically want you to use DNS. And so the last thing is, let's say you do have some WINS servers. You can essentially use Performance Monitor to figure out how many times it's actually being queried and how many responses it's sending. So you can say, hey, okay, I'm going to monitor this for a whole business cycle or a whole quarter or 6 months. And, oh, I only got like one WINS server request, which was initiated essentially via NetBIOS. Then I'm probably not using it in my network. The main takeaway here, though, that we tell clients is, hey, basically roll this out, turn off NetBIOS on your IT workstations. Make you guys, the guinea pigs, essentially. Then pick the marketing department and do kind of a phased rollout of disabling this. Now, when it comes to disabling this, there's a group policy, and it works by creating essentially a DHCP option. So you boot up your computer, you get DHCP. If this group policy is enabled, it says, hey, disable NetBIOS on your NIC. That's all fine and great. So my corporate systems, when they get DHCP, will have NetBIOS disabled. But if I have a laptop and then I go to Starbucks or I go to a hotel, those DHCP servers aren't telling me to disable NetBIOS. So we say, hey, let's kill it at the firewall level if you have SEP or McAfee or even Windows. Just block NetBIOS at that level, which is by far the best. Kind of going along with what Matt said with like ARP Watch and things of that nature, there's a few blogs out there that say, hey, while you're trying to figure out if NetBIOS is being used, you can set up a host, a Linux box on each of your subnets that will send out a fake NetBIOS query and then listen to see if it ever gets a response, and if it does, it can send you an email. I don't know. Like, if you have a lot of subnets, that's a ton of work. But hey, go for it. I don't know if that's really feasible, though. LMNR, disabling that actually is much easier. It is just literally switching a switch, and all you do is say disable it, and it's disabled forever. Doesn't matter what network I'm on. But we'd also say, as a layered approach, disable it on the firewall level. Another thing that we commonly see in networks is the ability to create DNS entries, essentially. So in an Active Directory environment, by default, domain controllers, DNS servers, essentially, will allow insecure updates, which means any system on the network can just create an A record in DNS, which essentially here you're saying that, hey, Google's at the 10.10.10.10. So it's kind of a man-in-the-middle attack. You can just add in whatever entry. You could, add intranet.local if you wanted, have it all point to you. Dynamic DNS insecure updates don't let you edit a record, so you can only add and delete, though. So this is something that you could do to say, hey, I want to add in Google. I'm going to have a website that I'm hosting with an applet attack, and get access, or I'm going to add in a WPAD entry. So every time IE boots up, it's going to come to me, and I'm going to get tons of creds. So this is a really quick fix, though. All you have to do is literally change a group policy setting to say only allow secure updates here. But this is something that we see in probably 50% of our clients. All right, switching to routing attacks. So we'll focus on EAGRP. Obviously, there's OSPF as well. But just to level set a little here, EAGRP is the Cisco's version of an interior routing protocol. Uses multicast. Basically, what happens is when a router joins the network, you send a hello packet and say, hey, I'm a new router. And other routers that are listening to the multicast will say, oh, okay, cool, let's create an adjacency then, and we'll basically swap route tables here. So after the hello packets go through, you send over your update packets, which contain all of the routes you know about. And the nice thing here, which helps us in this attack, is that EAGRP dictates that all update exchanges between routers need to be acknowledged. So essentially, you're just acting to say, yeah, I got your routes. Did you get mine? Yeah, I got your routes. Okay, cool. And then the way that routers keep track of each other is these hello packets get shot out every 5 to 30 seconds, depending on how you have it configured. And so if a router doesn't hear from another router, within like 2 minutes, it assumes that router's dead, and so now it needs to figure out a different way to get the data somewhere. So from an attacker's perspective, these hello packets aren't using authentication by default. So what we can do is pose as a router and send out hello packets and create an adjacency and download all the routes that that router knows about, and then potentially inject routes. So there's lots of tools that do this actually. Cane enable, by default, if you just turn on the sniffer and click the little EAGRP tab in there, bam, it automatically sends out a hello packet, downloads all the routes for you. The Hacking Exposed guys made a set of tools that are basically just wrappers of Scapy. It's Perl scripts, not user-friendly, kind of difficult. So go for it if you want, but I would recommend using Loki. It's awesome. It's basically your Cinia, if you're familiar with that, but for layer 3. It can do tons of different protocols. It's awesome. And then Matt suggested that you can always just bring your own router and do that, but that's intense. So basically, we're forming an adjacency, we're downloading the routes, and at this point, when we do our route exchange, we just don't send the router anything. We have no idea. We don't route anything, but we get all of that info. So it's a great way to map networks. This is one of the first things we do to map a network, because depending on how EAGRP is set up, I can figure out where all your subnets are, essentially. One of the things that we'll do too is just because you made an adjacency and you download the routes doesn't mean you automatically get to inject routes. Most of the time that's the case, but not always. And so one of the things we'll do is say, okay, we downloaded all these routes, and it looks like this environment is pretty much using the 172.16 ranges, let's say. So then we'll inject a route of the 192.168, 1.2, and we'll make it a /32 to see if that when I send that update, I get an ACK back. If I get an ACK back, I know that router has now taken it into its route table, and we're good to go. If you don't see that ACK, something else is blocking it and not allowing you to inject, even though you have an adjacency formed, and we'll kind of get into what that might be. Lesson learned, double check your CIDR notation, because you don't want to inject like a whole class B or something. We would recommend just a /32 first. So what's the fix here? It's pretty simple. Passive mode would be the easiest one. So basically, I have router A connected to router B over an interface. These have to exchange hello packets and route updates. But I have router A also having a switch hang off another interface, which has a bunch of users. And I would put passive mode on that interface to say, hey, nothing EAGRP goes out that interface. So basically, if I can't see those hello packets, I can't do anything. I can't form an adjacency, I can't inject routes, boom, good to go. Cisco recommends using MD5 authentication as well, which is good. So basically all of the hello and update packets, you have to know the key in order to actually have the routers listen to you if they're configured with MD5 authentication. So if you do actually see a hello packet and there's encryption there, and you can just look in the packet, it'll show you. You can try to crack that key and then inject. But MD5 authentication, the only caveat here is that you have to update all your routers at the same time, because if you have one key here and this guy doesn't have a key, they're going to stop talking to each other. One of the things that we found out when doing this attack was, like I said, hey, we got an adjacency, we're trying to inject, and there's no axe back. Well, one of the things we found out is that with distribute lists, you can pretty much set an interface to say, hey, I should only listen to or receive or send EIGRP update information that contains the 172.16 address. So when we tried to inject on the 192.168, it said, no, I don't care about that. I'm not going to do that. I'm going to ignore it. And so that was one of the things that we realized that, oh, okay, that stopped us from getting an ACK and not injecting. Usually these are used in conjunction with access lists to pretty much say, hey, only actually designated routers can talk to the multicast here. Like I said earlier, OSPF is vulnerable to the same type of attack. Essentially, for updates or for its hello packets, it uses link state advertisements. And then for its updates, it uses LSUs. And then RIP is also vulnerable to this. So these are one of the attacks that people say, hey, there's tools out there to POC it, but can you actually weaponize it? And walking through a quick example here, Matt will actually walk through it.
Yeah, so we've been seeing EIGRP a lot, but it took us a while to figure out a practical attack because we asked ourselves, wait, so you want to inject on an EIGRP routing protocol as a pen tester? That seems pretty dangerous. So finally we got the guts to do it and figured out...
With permission.
Yeah. Of course. We figured out basically a practical attack. So we listen on Wireshark, we see EIGRP packets, we think, okay, we probably have a good shot at forming an adjacency. So we form an adjacency with Loki or with whatever tool we went over. Then we actually dump the route updates. So we EIGRP, then after forming the adjacency, we dump all of the routes on the network. So this is great, we went over that. The next part is we actually inject a route on the network. So in this case, thanks to distribute lists, we target an internal host. So originally we started trying to target like 74.x, so Google, thinking people will browse to that. We stopped that and said, okay, let's target intranet or some site that people are going to go to. So we inject the route with /32. And that basically means if you don't set a prefix on Loki, prefix is your CIDR notation, that would try to inject 0.0.0.0. So again, set the prefix. And then basically disable ICMP redirects. So make sure that you get the ACK from the router saying that I acknowledge this. If Loki doesn't work, Loki doesn't always, you can try those other tools. So Easy EIGRP is a Linux standalone EIGRP client. There's some other tools. There's some great network engineering applications that we can just use for this attack. Disable ICMP redirects because you configure you as the next hop in this attack. So basically, you don't want your host sending back like, hey, this isn't smart to route it to me, which by default Linux is going to do, and make sure you have route forwarding on. If you want to pass that traffic. If you don't, set up something like Social Engineering Toolkit from Dave Kennedy, and also put a UNC path in there with an SMB listener. Now you're injecting in traffic, so every time that host goes to, say, the intranet site, it's now thinks you're the next hop. You launch the web page that you mirrored with a Java in there, applet attack in there, so now you have an interpreter session, and you also have a UNC path in there, so now they're auto Windows authenticating to you, and you have their challenge response hash. It's a pretty cool attack, and we see this probably in at least 40% of the networks we come across, These are large enterprise networks that have EIGRP on end user subnets. So this is the practical attack for that.
And just if you are going to do this attack, you will need two interfaces. One is essentially what you're going to form the adjacency with and send out your hello packets. You need to have a second one to route through, essentially because EIGRP has feasibility built in, and it's going to say, hey, you're sending it right back to me, what are you doing? So you just need two interfaces. Going on to VLAN manipulation. So DTP, one of my favorites here. Dynamic trunking protocol, totally different than VTP. Cisco proprietary protocol. Basically, DTP was invented in order to make setting up trunks for switches much easier. So basically, you have two switches, switch A, switch B, NetAdmin plugs them together. Cisco said, oh, we'll automatically trunk it for you. So DTP just establishes trunks. VTP is how you're communicating and configuring out VLAN information across those switches. So that's just two different things that sometimes people mix up. DTP does use the same domain that VTP uses. So basically, in order to create and manage VLANs using VTP, you just have to have a domain. And so each domain would have different VLANs if you're a really big environment. So basically, DTP will just inherently use the same domain. We'll kind of get to how that played into one of our assessments a little later. This is enabled by default. This still blew my mind, actually. I looked this up for this talk, and 2014 switches are being sent out, manufactured with this enabled by default on all interfaces. There's a lot of different modes for DTP, which we'll talk about real quick. But basically, if you plug in a Cisco switch, out of the box, this is going to be enabled. And the ports, each port will be by default on dynamic auto mode, which pretty much says, hey, DTP frames will be broadcasted, and it'll say, if you want to be a trunk, just let me know, just send me a DTT frame. Otherwise, we'll just continue on in access mode. The other mode that we can take advantage of is dynamic desirable, and this is pretty much would have to be manually configured by the NetAdmin, but it says, hey, I really want to be a trunk with you. I really want to be a trunk. Can you please be a trunk with me? Versus the first one, which just says, whatever. Trunk, obviously, it's a trunk. The port's a trunk. Access mode means that it's not a trunk and it will only be a normal user port. And then non-negotiate is a setting that will essentially stop the interface from sending out DTP frames. So all you have to do is plug into the network, open up Wireshark, and if you see DTP enabled, you can essentially become a trunk. And so once you become a trunk, you now can essentially hop or access all of the VLANs that trunk can access. You just would tag your interface. It's super easy to use, some tools like Yersinia for it. And one of the things that gets a lot of NetAdmins that I've ran across is that most of them are going into the interface and saying, hey, access VLAN ID 200, right, for port 3. If DTP is enabled, it will override that VLAN ID, and so it will win the fight essentially and still become a trunk, even if you designated that interface to be on a specific VLAN only. So basically, you'd use your Yersinia, blast out, say, hey, I want to be a trunk. And then in order to interact with all of the VLANs, just do sub-interfaces on your Kali box or so. You can see the commands there. Once you have the sub-interfaces up, you would just DHCP client, get IP addresses on them or statically set them if you need to. And the way that you can find what VLAN to actually tag is, after you create the trunk, open up Wireshark, sort on ARP, you're going to see ARP traffic from different VLANs, and then there'll just be a little tag that says what the VLAN ID is in the 802.1q portion of the packet. And so now you can say, okay, they're using the 163 VLAN. I'll tag my sub-interface as that. Couple lessons learned here. So I was on a job where I was like, oh guys, they got DTP enabled. We're doing an internal pen. I'm going to be a trunk. And it obviously went to a trunk, and since those guys didn't have any sub-interfaces set up before, all their stuff just died. So just, communicate before you do that. The next item is we use Yersinia to launch this attack. Yersinia is awesome, but in a lot of the protocols it supports, it does not tear down correctly. So if you kill Yersinia, what's going to happen is the port's still going to be in trunk mode. Every time to get this to stop, I have had to actually physically unplug and like kill the link. Now I only got to kill it for 30 seconds or so for everything to reset and go back to normal. But yeah, if you just close your Cynia, chances are it's not going to revert. Then the best part was we were on a job together, and going back to how this client was using VTP to spread out VLANs across their network, which DTP will inherently use as well. They had their domain name, which is arbitrary, doesn't have to be anything. They made it a domain admin password. So we opened up Wireshark and we're like, that's weird, that looks like a password. Like, why would you name your domain that? And we did anonymous enumeration on AD and found that there was an account name with what the first portion of that password was. We're like, it's a DOM admin. We're like, no way, I'll buy you a beer if it works. And like, tried it, we're DOM admins. It was crazy. Just kind of something you see in the field. Okay, quick fix here. Basically, as I said, all these Cisco devices come with this enabled. So you have to go into each interface and say switch mode access. So you're essentially saying, hey, you don't have the ability to be anything but in access mode. And you have to manually go into each interface. I have tried to scour the internet to see if there's a way to just make a global setting to push this out. I can't find anything, but if you guys know, that'd be totally cool. Range. Idiots. Okay, awesome. Just in case someone watches this later on, the gentleman said you can use macros to do this as well, which is pretty cool. I'm going to have to look into that. Appreciate the input, sir. That's awesome. Basically, you're going to then say switch port non-negotiate, which means stop sending DTP frames out. So Wireshark, if I'm a bad guy, I can't even tell that it's a possibility here. And then just assign your VLAN ID. So basically, for the DTP attack here, Matt will walk through kind of a quick thing.
Okay, so DTP, what does it get you? So we just talked a lot about how to do the attack. We're going to speed through this. We're trying to boil the ocean in this talk, if you haven't figured that out. So DTP, it's a devastating attack. So now we made a trunk. Now I figure out what VLAN you use for all your PCI traffic, and I tag that. Now I just bypassed every ACL in your environment, and I'm on your PCI network. Pretty devastating. Now the hard part is you got to figure out this ARP, or which VLAN that's on, and that's not always apparent. But if you can do that, that's really devastating. And now I just bypassed all your PCI controls. The next one is I'm a trunk, and now I can be a member of every VLAN that I want. Now I can launch those other two attacks we talked about, so ARP spoofing or LONR, NetBIOS spoofing, all over your network. So I take it from a layer 2, only local subnet. Now I attach it with your Cynia. I'm a trunk. I tag all my interfaces. Now I'm doing NetBIOS name responses for your servers, your clients, your whole network. It's pretty crazy. And then for time, that's all we're going to cover for that one. So real quick, real-world network attacks. So we went over some protocol attacks. This is how we compromise networks all the time. So we'll go for domain admin, but we'll also go for your network routers and switches. So first step is you obtain your SNMP strings. So then you dump configs, you analyze those, find your SNMP private strings, and now I attack your whole network infrastructure. So there's a few ways we do that. So the first way, you obtain your SNMP string. My favorite way is Prada, %X. A couple other guys made Prada, which is used to attack mainly SNMP and web interfaces with default passwords. So I launch that at your printers. One printer I find your network guy set up with the SNMP community read-write string that you use. Now I use that, and chances are that string's reused throughout your network, and you don't have ACLs on those interfaces, which we see all the time. Now I can dump every config in your network, figure out your local user passwords depending on the authentication preference I just took over your network. So this example, scanning public-private, I find one Cisco switch. Now I download all those. Next one, Prada. Here's some SNMP strings we encountered with private entries, or private community strings. Next one, type 16 bypass. So this is an oldie, 2001 vulnerability that we see all the time because no one updates their routers and switches because they just work. So all you need to do is find that one old switch that might be used for the IT help desk KVM or something that has this vulnerability. Now I bypass your authentication, I dump your config, I find that private string, now I reuse it and own your network. Or you just look for for ones without authentication. So if you search Shodan, Cisco IOS, last modified, these are routers and switches that don't require authentication, and in this case there's thousands of them on the internet. That's handy. Next, we dump the config. So we do that with Cisco SMB tools, Kane, many other tools support this. We dump the config. We look at it for type 7 passwords. We look at it for real passwords. Cisco keeps introducing new protocols that are easier to crack. So we had type 5 passwords. Those were a little harder to crack. Then they said, hey, let's take away the salt and make it type 4. Now I can crack those easy. And then we can use those to kind of own the network. That's basically, then we scan with that new string, and now we have every single network device. Now what do we do with that? Quick order, static routes, default highest administrative distance. This means that when it looks in routing preferences, prefers static routes. Then we use that to do kind of similar attack vectors. So now I add a default gateway, or a new route to Google. Now every time some user on your local subnet browses to Google, they go to me, I add that set in UNC path, and I own that device. So this is how we took owning a router or switch and made it practical. Really useful stuff. Then other things we can do, we can actually configure our port as a trunk and do that TTP attack. That's handy now. Or we can port mirror your whole network. Now I want to port mirror your mainframe because I know that has unencrypted FTP telnet. So I remote port mirror, issue RSPAN in a GRE tunnel. Now I'm port mirroring that switch in your server data center from my local client interface. And now I'm seeing all the traffic it has because I owned your private string on your SMP. And since we tried to boil the ocean, we don't have time for the HSRP, VRP attacks. We'll post them later. One last thing, bash bug, shell shock. You can do the same attack with this. Pretty cool. You just add a default gateway. Now, me as a pen tester, I prefer a shell, but you can do this and just add a default gateway to your attack box and just issue it via DHCP. So. I think we're running short on time. We have time for maybe 1 or 2 questions, I think. I don't know.
Next speaker yet? Yeah, go ahead.
Okay. Any questions?
So I actually just have 2 quick comments. So for the route injection, so I've done that with pen test too. It's a route that's targeting an external subnet, like or a specific site. If you just add a host route for the DNS server, then you can dynamically choose what you want to do and have it run it. And then also, I find so many networks that are just passively snooping the network. There are network management systems that scan using SNMP, so you'll get the...
Yep, absolutely. So there's 2 things there. The first one is EIGRP updates target their DNS infrastructure. Very good idea. The second one was a lot of client tools scan out SNMP private strings. So you just Wireshark, you do passive listening, and you see your SNMP community string. We've seen that all the time too, and it is effective. So all these different client management tools to detect new devices do this all the time. Really great, useful trick. So good comments there. Any other last questions? Yes, we're going to put our slides up. We hope to cover more attacks, but we'll put the slides up, and if you guys have any questions, our contact info is at the beginning of the slides. We're happy to answer questions. One last thing I promised my employer, our group is hiring, so if you want to work in attack and pen for the largest, one of the largest InfoSec offerings, we're actively hiring for just about any security position you could imagine. That's it.